can hear me and see my screen recording, that you can see my training manual. We'll provide a training manual at the end of the session. We'll send you this training manual in the chat as well, so you can definitely download it and see the settings and just most of the common stuff that a lot of people ask me about this specific product, the Luxpower off-grid SNA 5000 unit. So basically today, the purpose of today is just to run through some of the settings on the screen. And then one of my most basic stuff is just going to be like the type of circuit breakers and some requirements that we would like you to stick to when installing the units. What size circuit breakers we recommend you using. And we're going to just touch on that. And then from there on, we're going to focus on the settings on the screen today. I have a lot of clients that struggles with the settings on the screen. So my main purpose for today is just to go through the screen settings, just to explain what settings does. And if you want certain work modes, what you have to do to get certain work modes with this specific machine. So if there's any questions during the webinar as I'm going, please put a question in the chat there. Meow Meow will shout at me. She'll tell me I have a question and I can quickly go have a look at the question. And from there on, we can go on. So I hope all is well. So let's start. Okay. I see.
A minute. Sorry to interrupt, Jakob. Is the screen sharing document the one you shared me last time? If so, I can share quickly in the chat box.
Yes, you can share that one in the chat box 100%.
Okay, please go on.
Okay, so I believe that's everyone for now. If somebody comes on a later stage, that's also fine with me. I see we are 2 people that's here today. Okay. So basically, first of all, I would like the 2 people that is here at the moment. Do you know how to set up your Lux accounts? Do you already have a Lux account? Or are you new to Luxpower at the moment? You don't have an account and you would like to have an account. What's the situation? That I just know if you guys already have an account. Okay, you have an account. Okay, that's 100%. Not yet. Okay. Joe could see, I see you don't have an account yet. That's 100%. After this webinar, I'm just quickly going to drop my cell phone number here for you. Okay. Okay, that as well. We'll go through the normal setup for you as well. There's my cell phone number. Just save it, give me a shout out for the account. I'll assist you after this webinar. I'll assist you to set up your account and then explain to you how to use your account with your clients and your end users. And I'll explain that nicely to you. I'll do a private Zoom meeting with you and just run through everything there for you to explain everything for you. Okay. Now, basically for your account wise, you're going to use your account for basically everything that you do with this inverter while it's connected to the internet. From your account, you can monitor the status of your unit, as well as you can do settings remotely through your account. From your account, you'll be able to create end users accounts. That's the clients that where you install this unit will be able as well to monitor the unit, but they will have limited access to settings wise. So that means you don't have to worry at your end users accounts for the clients. They're going to do settings and stuff to mess up the whole installation. So we have different priority levels on this Luxpower interface. You'll have installers accounts. So that means that 90% of the settings that's able to be done on the inverters, you'll have access to it. So you can do all the settings remotely. You don't have to go out to your client's house to do all the settings for them on the screen. From there on the account, as I said, your end users will have the ability to see everything and just to monitor their system, the battery percentage, how many watts are they using at this moment and stuff like that. So for the basic settings for how to do your account, once your account is set up, you'll create a station. Once a station is created, you'll add the data logger. Now for the data logger, I'll quickly play you a 2-minute video that we'll also share on the chat with you guys, that you can also download the video to see how to do it. So I'm quickly going to share this video. If you give me 2 seconds, I'm going to start the video and then we can have a look at this video and we can go on from here.
In this video, we're going to show you how to repair the dongle to your modem. So if you've changed internet providers, changed the modem, or you want to just pair to the dongle in a different way, this is how it's done. So we plug the dongle in, and what we're waiting for is to make sure the bottom light is solid. When that's solid, that is giving out a pingable service. So we click on our Wi-Fi connections on our phone, and we're looking for the dongle number. So the dongle number on the is here, and this is what you'll find in your Wi-Fi settings. So click on that and pair to that as your Wi-Fi. So now we've paired to the dongle, we open up an internet browser, and in the address bar at the top there, we put the following digits: 10.10.10.1 and press go. Username and password is admin in lowercase, and sign in. So what you want to do, if it is in Chinese or any other language, just go to the top and press English. Once you've done that, so expand the page, and we're going down to the 4th option, which is station mode settings. Click on that, and at the very top you can see station parameter settings SSID. So this is where we're going to look for your modem. So you hit the word scan. Ours is TalkTalk, so I select that, press OK, and then at the bottom here it says password underneath enable. So on here we put our password in, and then we hit save. It'll ask you if you want to reboot the module. You press yes. You'll get this message that says wait 3 seconds for the module to restart, and then all we're doing is coming back to the dongle, and we're just waiting for all 3 lights to go solid. So as you can see, all 3 lights have gone solid. With us that took about 30 seconds. Just bear in mind, depending on your Wi-Fi signal strength, this can take anything from 10 seconds up to 5 minutes depending on the Wi-Fi quality. In this video we're going to
Okay, I hope you could have seen the video. If it was slightly not smooth everything, I'll definitely send the video in the chat, so you can definitely download this video, and then also give me a WhatsApp if you'd like me to WhatsApp this video to you. I'll quickly WhatsApp the video after the seminar to you, so you'll be able to connect the Wi-Fi dongle. This is one of the methods that I find personally to be the easiest method, or one of the easier methods to connect this dongle. You can also do it through the app. It also works nicely, but personally this method I have found that works the best, and I have clients also that tells me this method is quite an easy way to connect your dongle. So did everybody see the video, and is everybody happy with that so far? Just before I continue on that one, just in the chat, just say you're fine or something, then I can go on with the next steps at this moment. Okay, 100%, I see you. Did the video help you? I see you asked especially for pairing the dongle. Was the video clear enough for you to assist you in your problem that you're having with connecting the dongles? Okay, Now from here on, just a few basic. Okay, 100% definitely you can review this method and then we'll see how it goes. You feel free to contact me anytime on that number that I gave you. As you said, I'm the support side, this side, so feel free to contact me, and then I can also assist you if you struggle with certain types of settings and so forth. Okay, now at the beginning, as I said, the settings of the accounts, where we're going to set up an account. So that basically we've done so far. Connecting the data logger as well, we've done so far. So that's done for now. Okay, now from here on, how to use the Luxpower interface. That is one of the questions that I get a lot of people that keeps on asking me how one can use this interface to the best of its capabilities. I'll quickly log into one of my interfaces here, and then I'll share the screen on my side just to explain a few of the basic settings and workarounds around the accounts. I'm just logging in this side, and then I'll quickly share the screen for you. Okay. Okay, I hope you can see at the moment my screen that's shared here on the interface at this moment. Yes, I see it shared. Okay. This is basically how your interface is going to look when you are logged into your account. This is the first page that you're going to see. I'm going to do the interface that you get when you go to Luxpower login. If you press in Google Luxpower login, you'll get our Luxpower login page. Type in your credentials with your password, and then you'll be able to log into this specific account. Now, on this account that you see here, let me just go to a station that I know that works, so that when your system is up and running, let's go to this. Okay. So on the monitoring page, as you see at this moment, the client is having load shedding, and his house is still working perfectly. So that's basically what you want from your system is there's load shedding, you have power in your house, and you can go on with your normal day living. Now, as you can see on this specific page, it's quite self-explanatory. There's the power from your panels to your inverters. From your inverters, power to the battery at the moment, it's showing that it's charging. And then this is the backup of the system. This is the backup power the system is providing at this moment. So this is basically how your monitoring page is going to look. This system, as you can see, there's not one inverter in the block, but 3 inverters at this moment. This means this system is in parallel. This guy has 2 5-kilowatt inverters at this moment that's running at his house. As you can see, they fairly divide the work between the 2 of these inverters. They're fairly charging at the same rate, and their discharge, the EPS power as well, is fairly close to each other. So my SN 5000 units is fairly close on the load division of it. So it divides the load basically almost perfectly between the 2 as far as possible. So that's quite nice on this specific units. Now from this page on, you have at the top, you have your data that shows how many kilowatt hours you have done for the day from the panels, what your total discharge from the batteries, and today's charging as well, how many kilowatts you have charged for the day. And this is for the grid. This guy haven't had any power for the day so far, so he won't have any information there on his side. Now, this is your total consumption for the day, what amount of power you have used for the day. So this is basically the first page that you'll always log into, and you'll see this page. This is also the page that your client will see at the end user stage. So if you create an end user's account, your client will also see this specific page, and this is what he'll be able to monitor on his side. Now from here on, I'm going to go to the installer side. So for you guys, one of the things that I get a lot of people that ask me about is how to create a station and how to add a data logger to my stations. So from here on, your data logger is already on the internet with that video that I showed you. Now with that video, all three lights is green. So from here on, you go to your configuration tab at the top. From your configuration tab, you'll create a station. So let's say your station name is Jan. So the station name is Jan. That's the client's house that you're at this moment. You create a station for him on your installer's account. Then we are in Africa, South Africa, and we are at GMT +2 is our time zone, and daylight saving, we say no. So now we've added the station. So now Jan station is basically added. So here at the bottom, you'll see here's my newly created station. Now for Jan's station, we are going to go to the station management tab to the side. We are going to tell this station, I want this data logger to be here. So now you'll see on your data loggers, there's a BA number. So you're going to type in this full BA number that you get with your logger at the moment. Then you put in that whole serial number there of the logger. And then on the logger, you'll also see there's a PIN. Now the PIN is the PIN on this logger. It's usually 5 digits. The PINs, so you can enter the PIN, and the PIN is cap sensitive. So it means if it's a capital letter, J, K, whatever, it needs to be a capital letter on the PIN itself here. Then you just say add, and then when it's added, it will say it's successfully added. Now, a station that the data logger is added to, let's see if this client has added his. Okay, this guy haven't added this yet. Okay, just give me a second. Let's just go to this guy. Okay, this guy's station name is Bucks. So I can go on to his station. Then your loggers will show like this under your station. You'll see on your information at this status, it will show you if the system is happy or not. And then from there on, the people who is paralleling 2 or 3 units, you add all the data loggers under the same station. So if you have a 3-phase system, all 3 loggers comes under the same station that you've created. If it's 2, 3, 5 units in parallel, in single phase parallel, all data loggers is added to the same station. So for this instance, this guy has 2 in parallel. So in his instance, both loggers is added under his station called Bucks. Now, if the data loggers is added, you want to tell the monitoring system, all these inverters is working together. I would like all the information to be put together, and you only see one monitoring page so that you don't have to jump to inverter to inverter to inverter to see the status of all of them. You can tell the system is in parallel, and it will combine all the data loggers information and only give you one page. So to do the paralleling work, from here on, it's quite easy. You go to parallel. All you do is at parallel index, you put 1, save. You go to the second one, you put 2, save, and so on. You go down the list. But always try to make your master inverter your number 1, 2, 3, 4, 5 on the paralleling while it's on the app. Now, the paralleling on the app has nothing to do with the physically settings on the machine for doing it while in parallel. It's only for the monitoring to put all your information on one monitoring page so that you can see all your information of this inverters in one complete block like this. So that's basically for adding a station, adding your data loggers to the station, and having the capabilities to monitor a parallel system as well as only a system that has one unit in it at one monitoring page. In a parallel system, you'll see all your inverters numbers will go down depending on how many you have. Your serial number will be there. The specific information will be there. Now, on this monitoring page, here is the history of what your machine is doing at what given time. You can see how many PV power, what's the batteries charging, what was your consumption, is the batteries discharging, what is your status at this moment here. Now, from the monitoring page, if you have a look to the right-hand side of it, is a column called data. Now, this column shows you basically the history of your machine. Here on top, you can go to the specific date. If your client tells you, listen, my machine went off for what reason or whatever, you can come to this page and he tells you it was on the 12th or the 11th or the 10th of April. Then you can go here to the 10th of April all the way and see the history data of the specific machine. So for instance, on the 13th of the month, this guy had a maximum production of PV volts, was on 260 volts there. If you want to go to the wattage on the specific inverter, you go to wattage down there and it can show you the peak power of watts that it got, 2.2 kilowatts. Then this specific block here is dedicated to one machine only. Here, your information isn't combined. So from here on, the only thing that you do is you go to the top and you'll see your serial numbers for your two machines. You select the next machine and that one's information will be displayed. So on your data side, your information isn't combined like the monitoring app. So you can individually see in your system which inverter done at what specific time. State of charge, how the batteries was running down and charged up. What was this inverter gave 819 watts at this specific time. So you can go to the other inverter and you can see this one gave this amount of power at what given time. So you can basically track each inverter individually through all the days going backwards. So that's, I think it goes up to 100 days, if I'm not mistaken, that the data is saved here. So that's basically if you just want to go troubleshoot your inverter to see why my batteries is still flat, what is happening, and so forth. Now from your data page, you can go onto your maintain page. Now this is one of the bigger questions that a lot of guys have. How can I do my settings remotely? Now, if your account is set up correctly and your data loggers is added on your stations, you can set any of your inverter settings remotely. You don't have to go to your client's house to do any settings. So for you to be able to start with any settings, you have to press this read button. Now, the read button, you'll see your fields are starting to populate. And as soon as your fields are starting to populate, you just give it a few seconds so that the server can relay all the settings and information of that system to you. So let's just give it a second or two to be finished with the populating. Okay. So if the populating is done, you'll see the read button goes back to the read. It doesn't have the dots at the end anymore. So that means you have done with your population of the settings. Now, from here on, you'll be able to set what type of battery you're using. This guy is using a lithium battery. He's using shorter batteries that is set to the Luxpower protocol. So that's why it's set. Here you'll see you have a lot of batteries that you can choose from. Your PylonTech batteries, your GSL batteries, Luxpower is usually shortos, your Dynas, BYDs. You have all your batteries that we support, you can see in this list. From there on, you can type in your nominal battery voltage. For lithium, it's usually 51.2, but a lot of people put it on 52. That's fine. Then on MPPT input mode, here you tell the machine how you've connected it to your solar panels. We have the different type of options here. We have two MPPTs connected to the same string. as well as 2 MPPTs connected to different strings. Now on this instance, for when it says two strings connected to the same MPPT, of 2 MPPTs connected to the same string, what's going to happen here is that's when you have panels that is bigger than 13 amps on the panel operating amps. So because my MPPT is only 13 amps and has an operating range of 120 to 380 volts and has a range of 100 to 480 volts, the MPPTs. And at 13 amps, and I have 2 MPPT. Machine. So okay. Can everybody still hear me? My thing just said internet connection. Okay, it's fine. So from here on, settings wise, normal and standby, you're always going to select normal. Green function, you always disable the green function for a unit, because in green function mode, if your inverter pulls less than 60 or 70 watts for, I think, a half an hour, your machine will switch off. So green function, you always disable. Then this buzzer, that's just basically the buzzer sound that you hear when you press the settings and so forth. You can decide if you want to disable it or enable that buzzer. Now, restart inverter, that's only if you want to restart your inverter remotely. From here on is your EPS voltage set. Now you can set this voltage to 230. This client wanted it at 240, so he set it at 240. But this is the voltage that your inverter will relay from the EPS side of the inverter. That's your AC output of the inverter will be the voltage that you set it here. Then EPS frequency, 50 Hertz. That's how South Africa in here we do the 50 Hertz. Then max generator inputs in watts. If you connect the generator to this machine, you can put the maximum amount that you would like the generator to use of your inverter on this. So if you have a generator that's 5 kilowatts, you don't want it to pull more than 5,000 watts. But in my opinion, if you have a small generator, at least put this value of 50% of the maximum capacity of your generator. So if you have a generator at 5 kilowatts, put it at 2.5 kilowatts, that's 2,500 watts, so that you know that you're safe and you won't overpower your generator and it will cause dips. Now, AC first. Here's one of the first settings that a lot of people struggle with. If you install your inverter, your AC first settings will always be 2359. Now, if this is like 23 and 59, as you see on your screen at this moment, that means your inverter will use Eskom every time, no matter what happens with the panels and the batteries. If there's Eskom, it will use Eskom. And we don't want that at this moment, except if the system is purely a backup system. Now, if the client has installed the system to save money, then we will recommend you to change all these values to 0000. And then if you have all your values at AC first time 1, 2, and 3 to 00s like this, you press set next to each one, then your system will tell you it was set successfully. That means your setting has taken effect on the inverter. Now, the next setting that a lot of people ask me about is our hybrid setting that this off-grid inverter has. Now, this means this inverter has the capabilities to use your PV power and AC power combined to provide your loads of your house. So this means if you have a kilowatt of PV power, but your house is using 1.2 kilowatts, that means this inverter will take 200 watts from the grid just to fill up that last bit of amount of power that the panels can't provide. And it will use that 200 watts from the grid and not from the batteries, if you enable this setting. Now, this specific setting will always allow your inverter to backfeed a slight amount of power. you can have up to a half a kilowatt, so 500 watts of backfeeding power through the day. So if you have a system that is extremely sensitive for backfeeding the meters, then you can't use your PV and AC jointly function. Then it will trip the meter at the box. This inverter also has the capabilities to backfeed. If you have an inverter that's backfeeding, if you want an inverter that can backfeed into the grid, this inverter can backfeed. Now, at this moment, I've disabled the backfeeding function. This guy doesn't want his inverter to backfeed at all. So he has disabled it. If you enable the export to grid, all available PV power that can't be used by charging the batteries or the house loads will be exported to the grid, and you can put the percentage here. So if you see you only need 2-3 kilowatts a day to be exported, you can play with this percentage up and down until you've met the amount that you would like your system to export, so that you can roughly balance out your meter with the usage, so you don't go into the negative amount on your meter. Now, parallel settings is quite easy on this machines. You can put it on single phase parallel, like this guy has 2 units, so that's why it's on single phase parallel. There you can go to 3-phase parallel. There's no master settings or anything on this inverters. The first inverter that you switch on is my master in the string. So you switch on the first inverter, then the second one. The first one will be the master. If you have a 3-phase system that you selected, you can tell each inverter which phase it must be, your R, S, or T phase. You're going to assign each inverter to its dedicated phase. Now, if you have a 3-phase system, we get a lot of warnings on the 3-phase system that says AC inconsistent. That means the phase that you've selected here for the inverter is not the same as the phase that it's detecting from Eskom. So all you have to do is you can change the phase here on 2 of your units, or you can physically go swap the 2 phases on the input side of the 2 inverters. Then your problem should go away. Then your phases will be correct. From here on, you'll see our charge settings. Now at charge settings, this is the amount that your system will charge from any source. So that means it's the PV, the AC combined. It won't go higher than 110 amps. Now for a system that's communicating, it is not necessary to put this charge current limit, because the BMS will limit the amount. But I always like to be on the safer side. So this amount I will always put on what my battery manufacturer says the maximum amount of charge is for this batteries. So if you have, let's say, like shortos, you won't really charge a shorto more than 50 amps per battery. If you have 2 shortos, you can go up to 100. If you have 1 shorto, leave it at between 40 and 50 is recommended for charging like your shorter batteries and so forth. Now, here is your lead acid settings. Now, lead acid settings can be used while you have a lithium battery that can't communicate. So if you have like a Freedom 1 and those batteries that can't communicate with my Luxpower inverter, you can basically go to your lead acid settings. You're going to choose by your battery type here. By lithium, you can choose no battery, lead acid, or lithium. In this case, you are going to choose lithium if it can communicate. If it can't communicate, lead acid. Then you'll basically use this specific settings here. You'll put in your charge voltage, your float voltage. This equalization period settings that's here is not applicable at the moment. It's a function that isn't activated on this machines. So you don't have to worry about the specific function. It's not activated on the machine at present. AC charge. Now, AC charge is a fairly difficult setting to get correct. Because if you select AC charge during that AC charge time, it will use Eskom as fast as possible to provide power to your batteries to charge it, as well as provide power to your house. So during an AC charge time period, AC will provide power to your house. because you can't charge your batteries with AC, but the panels must still give power to your house. It can't work around like that. So if you have your AC charge time set to, let's say, from any time during the day, during that period that you set it, your machine will use AC power to provide the loads of the house if the parameters is made for AC charge to start charging your batteries. So that's also one thing that a lot of people confuses itself with. You can have the AC charge settings to time, voltage, or SOC. Now you can tell it during the specific times, if my voltage goes below whatever amount you set it, it will start charging to whatever amount you set it. So this is if my battery goes below 46.4, it must charge my batteries up to 48. Or if my percentage for a battery that's communicating below 20%, it will go up to 100%. That values you can play around with until you are happy with your AC charge settings. Now, generator. This is a fairly easy topic to cover, but it's also a topic that a lot of clients don't understand very well. Your generator has to be within the acceptable range for my inverter to accept it. If you have a generator that fluctuates a lot with the volts and the hertz, there's a very good chance my inverter will see it, but it won't use the power because it's not happy with the stability of your generator source. Now, for you to be able to use a generator charge, your inverters has to be on the newest firmware. I'll also show you when I'm done with the settings how to update these inverters to the newest firmware using your own account. You don't have to contact us, you can do it yourself, and it's quite easy. So for generator charge, you can as well works the same as AC charge. You can put it according to battery voltage or SOC, and from there on you can go. Just remember, after every setting that you change, you must press the set button. If you don't press the set button, the setting won't save on this inverter and won't reflect on your side if you read all your settings again.
华为的电脑可以连苹果的耳机吗？
Now from here on, you'll see your generator battery current. Now from here on, that's the amount that you will allow your generator to charge your battery. Now, if you want it only to charge at 10 amps, 20 amps, or 30 amps, you can set it here. Try to use your generator not more than 50% of its capacity to do work on the generator, on the inverter. So that means you have a generator that is not overloaded, and it will still provide a constant and stable source of electricity to my inverters. Now, discharge settings. Here, it's also quite easy to set. Discharge settings, you can put it against voltage or SOC. Voltage is for batteries that can't communicate, and SOC is for batteries that can communicate. This side here is if you put all your parameters in volts. Now, battery warning voltage, that's only to give you a warning if your battery is at a certain level. Discharge cutoff voltage, that's the setting where my inverter will completely stop using will stop using battery power. My inverter will switch off at this point. So if there's no ESCOM and you reach this setting, the inverter will stop providing power and it will switch off. Now, my on-grid EOD voltage is a very important setting. This setting is where you are able to tell this inverter if my battery comes to 42, or let's say, for instance, we know it's load shedding, you put the setting to 48 or 49 volts. As soon as my inverter gets to this specific percentage of voltage you set it to, it will stop using the batteries and it will start using grid to provide my loads. So this is to keep the inverter and the backup system able for when there's load shedding, so you can still have slightly a better amount of backup power that's left in your batteries. But if you do this setting, your inverter won't use all of your batteries. You won't save as much as electricity, but you will be able to have a backup amount of power always in your batteries. Now, discharge current limit, that's the limit that you tell this inverter you may not draw more than this from your batteries. Now, I don't know, some of you get a notification that says EPS overload. As soon as you get a notification of EPS overload, that basically means you've drawn more amps out of the battery than you've told the inverter that it can pull. So if you have an EPS overload and you know you're not on the maximum of your batteries, just come make this value slightly higher, then the EPS overload warning will disappear. This is the same settings as this side, your warning, your discharge cutoff SOC, where the inverter will stop using the batteries and switch off, and your on-grid EOD settings. Now you must always remember your on-grid EOD settings must be the same as discharge cutoff or higher. You can't set this one lower than your discharge cutoff settings. The system won't allow you to do it. And that's basically the settings that you'll be able to change on your side. From here on, for the update, just for interest's sake, I know there's a few people that would like to know how to update my systems by themselves. You can go to this option on the left-hand corner that says remote update. Now, if you go to remote update, you'll see all the inverters that's under you. But if you only want to see the specific station that you're working, you just click that box that says station. And here you'll be able to see the firmware that the client has. This client is on the newest one, 246370. So his inverters is on the newest firmware that's available. Now, for you to update the system, you'll press the standard update button here. As soon as you selected the standard update, your machine will show you on this side that it's starting to update. So that's basically all that you have to do is click your standard update and it will start to update. If it's on the newest firmware, you can press the standard update button the whole time, and then it won't show you the update that's happening that side. So for this system, we can still do a new update. I see there is a new release at this moment. So if you press the standard update, it will throw it up here and the system will start to update. When your updates is done, there's 3 updates on my inverters, my main board, my MPPT, and my communication board as its updates. That's why the 24 is for the MPPT, the 63 is my communication, and the 70 is my main board, if I'm not mistaken. But that's how my firmware code is developed there. Then if you have a parallel system, always make sure that this firmware code here that you see is exactly the same. Otherwise, you'll have trouble in a parallel system. It won't communicate correctly and it won't do what you tell the system to do. So always update the parallel system to the newest firmware so that you know all your inverters is on the same firmware. From here on, you'll be able to see an update record if your updates has been done. You'll see on my side, I've canceled this update. So they will say it failed after a few minutes. But from here on, you'll see here's a system that was updated. It will say successfully on the first update, the second update, and then there will be a third one that's successfully. So let's see where we can, here's an instance, this guy I've updated in the week. So you can see your first update is successful, your second is successful, and your third is successful. So that means you've done the one inverter. So there has to be 3 updates that shows successful for you to be able to know you've done the update correctly onto the newest software. This update method is available to all the installers. If you can't get a hold of us, you can update your own system with what I've just showed you. So you don't have to panic and contact us and can't get a hold of us and everything and start to panic on site because your machine isn't working. Just log into your account and you'll see you'll be able to update your system. No problem. And you can do it by yourself. So from here on, that's basically how my interface works, the main stuff on the interface that you can access and you can use. At this moment, is there any questions on your side that you'd like me to repeat on the interface or not? You can easily just pop in the question on the chat. Let me just quickly have a look here if there's anything that somebody is asking here. So you can quickly, I'm going to give about a minute or two for you to type your questions here so that I can see if there's any questions that you'd like me to answer on the monitoring page before I move to the physically the inverter settings on the screen. That's on the Yahoo screen camera. So I'm going to give it chance till, let's say, about 2-3 minutes, so you can type your settings. At this moment, I had this question this morning on the group as well. Dustin and them confirmed at this moment, it's looking like my system is not compatible with the Narada batteries at this moment. For you to use your Narada batteries at this moment, you're going to have to come to the maintain setting. You put it on lead acid battery, and then as well, you're going to have your lead acid type. You're going to put in how big this Narada battery of yours is, and then you're going to go down to your charge settings. You're going to put in your charge voltage that the manufacturer tells you is your charge voltage and your float voltage, and all the way down to discharge, your discharge cut-off voltage. You're going to put in your low end of your battery. You're going to put it there. So at the moment, the Narada batteries, as I understand, is not supported. Dustin says, it says here Narada, but at the moment, it seems like it's not communicating correctly with our inverters. I know they are busy with it, so hopefully in the next few months or so, we can have the update and the capabilities to fully communicate with your Narada batteries, but it will be there. Is there any other questions that someone would like to ask? Where can you see that the BMS comms is active? Okay, for you to see if your BMS communication is active, first of all, if your inverter is not communicating at all, you'll see it won't show you anything of percentage wise or volts. It will be like your system doesn't have any battery. It will also tell you here communication fail, as well as if you click on the battery, you can see the shorter battery is communicating 100%. There's 2 of them. As soon as you have the shorter batteries that's communicating with your inverter, and there's 2 in parallel, the BMS will tell this one, there's my charge limit at 50 amps per battery, so that's 100 in total, and there's the discharge limit as well. So if your BMS is communicating correctly, then you'll see this information here. So I hope that answers your question. If you want to be very technically, you have the capabilities to I just want to go to, okay. This one to quickly load. Then I can also show you at this moment where the inverter and the communication is happening. So if you go to your data source, history data, then you can go all the way. Just looking for that tab here. Okay, max charge. You see this max charge here. If your BMS is communicating and you go all the way, I'm just going to see a timestamp on his side that should be, all of this is during the night, so that one will stay continuously 100%. But your BMS information will be displayed here as well. As soon as the system's battery is coming to the fuller side of it, you'll see at max charge, you'll see this value will start dropping your BMS information. Let me just quickly see if I can find you a system that has that specific data there for you. Just quickly going to see if I can find a system that's online that I can quickly show you to see if the system. No, this client is using lead acid batteries. Okay, I'll just find quickly a system for you to show you, but on that one, you'll see where I showed you, your BMS will give you at that certain moment what it wants. You can also double check on that history data on that block that I showed you. I see you ask here, for some commercial clients require electrical drawings before installation. Do you have a software that you have for us installers or that you can recommend? At this moment, we don't really have something that we can help you there with. We are only providing this units. So that you're going to have to see if you can find an electrical engineer or a company that is able to give you drawings like that. We don't have anything that we can provide you at this moment to help you with this specific question. I'll see if I can maybe get somebody to give you guys an option. I'll see if I can find something. I'll post his number on the two Luxpower groups that there is. So if you're on the groups, keep there, and then I'll watch on the groups. I'll post this specific number for you at this moment. Then you can contact this person. I'll just see if there is, if there's any person that we know of that can assist you in that thing. And if you are not, on the groups, please leave your number in this page, and then Meow Meow will add you on the Luxpower groups that we have for support this side. That's the questions has been answered by me, Dustin, Joe. So we have a few guys, and Andy is also on some of this group. So Andy will also help you with some questions that you might have at this moment. Yes, the training video I'll definitely share on the support group. So the video on how to link the dongle, I'll also put it on the group. I see you can, we'll add you definitely there. Then the other thing on this moment is I am in the process that we are going to start making short videos for certain stuff on this inverter. So within the next month or so, we'll be able to share links with you guys on the group for labeling the videos for battery settings, and it's going to be a 1 or 2 minute video only on battery settings, parallel settings, AC first, charge settings, and your discharge settings, so that we can keep that videos nice and short. That will be beneficial for you. If you wonder about something, then all that you have to do is just go on the group. We'll put it in the description for the specific channel that we're going to use. You can click on that channel and you can go search for the specific small video that you have. Okay, so that's basically it. If there's any other questions, okay, hardware wise, I'm going just to cover it for the inverter side, for the circuit breakers and that type of stuff we are going to use. Yes, I'm going to do that quickly as well. I'm done with the online monitoring system now, so now I'm going to move over to back to this manual. Okay, for your installation on these machines, we require, not require, but we recommend that you have a 25 input breaker, amp input breaker, a 20 amp output breaker, an earth leakage, an SPD, and lights to tell you if the inverter and the grid is on, so that you know where the power is coming from if you want to work on your house on electrical system, so that you know the inverter is switched off, the power to the house, and so forth. Then as well, an important thing that we recommend is a changeover switch. Your changeover switch is not that expensive, but if something goes wrong in your systems, the client has the capability just to switch over the house to Eskom. We have systems that the settings is not done right. The client can't get a hold of the installer and they are sitting without power in their house. Please put in a changeover switch for your clients to have the ability to change over from the inverters to Eskom to provide the house with loads. Okay, now on SPDs, that's a surge protector device that we have this side. So on your SPDs, we recommend an SPD on the incoming line. So that means the power in line, your AC into your inverters. We recommend an SPD there. We don't ask everybody to do it, but as well an SPD on the line that's going out to the house as well for extra protection. But SPDs are fairly expensive, so we'll only recommend one on the ESCOM side because the inverter will regulate that's what's coming out of it. So it's technically not necessary for an SPD on the AC output of the inverter, but if you have the chance and the funds, you can add an SPD there as well. It's always safer to add SPDs on the input and the output side of the inverters if it's possible. So that's on the AC side of this inverters. So it's basically, just to recap there, a 20 amp output breaker, a 25 amp input breaker. The reason why we use a 20 amp output breaker, it's roughly 4.7 kilowatt of power before it trips, is the reason we don't like the inverter to trip under load. So that means when you don't have ESCOM, this inverter is capable of giving you 5 kilowatts worth of backup power if ESCOM is not there at the moment. Then you can get 5 kilowatts of power. But if you go over 5 kilowatts of power, the inverter will trip. And it is not a healthy thing for your inverter to keep on tripping. It's rather safer for a 60-70 Rand circuit breaker to trip than your inverter. So that's why we have a slightly smaller output breaker than is allowed of that the inverter can give you. So your circuit breaker will trip and not your inverter. Now, the reason for the 25 amp input breaker is you'll see this inverter has the capability to pass through the current. So that means if you pull more than 5 kilowatt out of it, it will switch to ESCOM and all that current will run through the inverter to the house. So you can put 6.5 kilowatt through this inverter without tripping the inverter if ESCOM is there, but then you'll have a pass-through current of 6.5 kilowatts through my machines. Now, this machine isn't designed to do that. It will allow it, but if you keep on running that type of amount of power through my inverters, it won't have the lifespan that you would expect from it. So that's why we put a 25 amp input breaker, so that we can just protect the system there as well. If you go over that amount, it will trip and your inverter will still be on the safer side of life. That's basically for my AC side. Now, at this moment, formal wires is more than enough on an inverter. 2.5 is also fine. But as soon as you parallel the two inverters, the AC output of the two inverters will have to go to a 4 or 6 mil output to your main breaker. But if it's possible, I like to do all my electrical work from the inverters and so forth with formal to an earth. That's what I like to do. I know it's slightly more expensive, but I like to have my wire slightly thicker than necessary, so I know everything is fine on this instant. Then on the DC side, I see you have a question there on the DC side for the DC breaker. Yes, you can use a DC breaker instead of a fuse. The only thing with DC breakers is the more that a DC breaker trips, the less resistance it is to the amps. So at the beginning, it will trip, let's say at 16 amps. If you trip it again and again and again and again, it will become lower and lower and lower, and you start tripping at 15, 14, 13, 12, and so forth. But yes, you can use a DC circuit breaker if you want to use it in the places of fuses. That's also fine. You'll see we just recommend that you have fuses on your positive and negative of your strings. Yes, the values of my MPPT that's a working range. You'll see this MPPTs only really start to give you power above 120 volts. So if your string is above 120 volts till 480 volts, it will give you power. But we recommend that you keep my MPPT within its working range. So if you use it between 120 and 385 volts, you'll be 100% within my MPPT's working range at this moment. So that's basically for my MPPT side. So positive and negative fuses, SPD as well. On this system, a 500 volt SPD is sufficient for the MPPTs. If you run it up to 480 volts. If you have strings that's less than that and you know you're not going to upgrade it, you can adapt your SPD to the voltage that you're going to run. Now your panels that's coming down, please have an isolator switch or a DC circuit breaker that's big enough for the current that you're going to run from your strings to the inverter, so that you have the capabilities to switch off your panels at any given time without having to loosen wires and work on live wires. So this is for your own safety. If you have a system of 300 volts at, let's say, 10 amps for a 330 watt panel, you're going to have 3 kilowatts that's running through that wires. It's extremely dangerous to work with DC volts at 3 kilowatts of power. It's very dangerous. So please have an isolator switch installed so that you can disconnect the panels from the inverters without having to loosen a wire if you need to do something on the inverters itself. We recommend on a 5 kilowatt inverter, 125 amp fuse links for the batteries and a 35 mil battery cable. The battery cable is going to be dependent on the length that you run. If you're going to have a few meters of battery cable that you're going to have to run, you're going to have thicker cables to run that current at a longer distance. So this is my DC side, quickly explained to what you want of this inverters. Is there any questions on the AC and DC side that you would like to know about some hardware or something on that? Okay, surge protection, I've explained that. There where you ask the AVR, is it on a generator or where do you use that AVR? Because usually it's with the generators that have that AVRs in them. And I see it's okay to use a DC breaker instead of a fuse. I've answered that question as well. So is there any other questions that one of you have on this one I'm going to give about? Okay. Gareth, I've never used one. I've never came across an installer that has used one. I can't see why you can't use it, because it will regulate everything to keep it within specifications. I'll find out. Please leave me your number. So after this session, I'll just quickly have a chat with my Luxpower team to ask them what's their opinion, if it's necessary on their side, and then I'll get back to you on that question. I'll just ask them what's their opinion on it. Okay, the neutral earth bonding. This is a fairly common question. At this moment, yes. If your machine is working in an off-grid environment, that means there's no ESCOM, you have to bond your earth and neutral. Otherwise, you're going to have a floating earth and your earth leakage won't function as it should. You can bond if there's no ESCOM and there is no, there's never going to be ESCOM, you can permanently bond your neutral and your earth together on the inverter itself, as long as you have earthed your inverter as well. My earth on this inverter is earthed to the body. So my two earth ports for PV out and PV off, for AC out and AC in, is earthed to the body itself. So you'll see on this inverter, if you earth my bodies as well, you'll have your whole system functioning correct as well. And then your earth that you run from your AC output and AC input, you can combine them to an earth rod, and then you can also combine your output neutral with the earth as well to bind your neutral and your earth so that you don't have a floating voltage. What size of cable will you use from inverters back to main DBs for 2 and 3 inverters in single phase parallel? That's going to depend at this moment. It depends if you have 2 of these inverters. I will go 4 mil should be fine for 2 of them, but I'll always like to go a size bigger. So I'll recommend 6 mil for 6 mil for that, because 6 mil cable can run up to 41, 42 amps. So it depends on what's your application. So for 2 inverters, 4 mil should be fine. But I'll go rather for 6 mil cables on 2 inverters. And if you have 3 inverters, that's pulling 50 kilowatts. 50 kilowatts is going to give you 15 kilowatts, excuse me. 15 kilowatts is roughly going to be around 60 amps. So there I'll go to a higher size wire, like an 8 mil or something like that, depending on the distance. And then I see you ask as well here, Peter, is the inverters on the list for approval hybrid inverters for the Cape Town list? Yes, it is, but not my SN5000. This unit that I have the training on today is an off-grid unit. So it is not on the NRS approved list or the Cape Town list, this SN5000, but my fully hybrid version, my LXP, I'll just type it there, my LXP 5 kilowatt inverter is on the NRS approved list, and it is on Cape Town's list. So if you want to install an inverter in Cape Town from Luxpower, you may use my LXP 5 kilowatt fully hybrid unit. It's an IP65 rated machine, 5-year warranties. It's a fanless unit as well. So you can basically put this unit anywhere in the house. It's fanless, so there's no noise of fan or anything on this unit. I just need to post that message to everybody at LXP 5 kilowatt, and there's it. So that's my fully hybrid version. Is my LXP 5 kilowatt unit. That one you might use in Cape Town. So I presume that's most of the questions that you have. If there's any questions, I'm just gonna, yes, the Word document is shared. We'll share it again at the end of the conversation. We'll share the Word document as well. I'm just gonna post my cell phone number again in this chat for the people that came in late. There's my cell phone number. Any specific questions that you're wondering from, please feel free to WhatsApp me on this number, and I will get back to you. If I can't answer you personally, I'll ask my Luxpower team to give me their recommendations, and I'll get back to you as soon as possible. So that's basically my DC side. Now, battery communication is one thing that we have a lot of problems with. You'll see my inverter cable that's from the inverter to the battery is a crossover cable. My number 3 on the inverter goes to number 5 on the battery, and 4 stays on 4. Please make up these cables. Most of our providers that's buying from us and that's supplying this inverter is starting to make up these cables as pre-made up cables. When you buy the Luxpower unit, you'll see 4 stays on 4 and number 3 jumps to number 5. You can make this cable yourself as well if you'd like. But this is the battery cable for most of your protocols on your battery. That's your pylon, your diners, your shortos, your batteries, all of that batteries. 90% of them uses this specific cable layout for your CAN H in your CAN L port. That's for this manual. I'll give to you again at the end of this session. I'll send it in the chat. You can download it again. This is just the settings that we went through, just to familiarize with them. This is the settings that we've explained online. Now, one thing is your parallel settings. Now, this is quite some headaches for some people, but if you understand it, it's not that difficult. Now, this is a parallel system with 4 inverters in single phase parallel. 3 phase will be exactly the same, only with 3 inverters. Your communication cables between your inverters is straight communication cables. So that means it's a 1, 2, 3, 4, 5, 6, 7, 8 on the one side, and it's the same through to the other side. Your pins is not crossed over on your RJ45 cables. So for parallel, you're going to start with your master inverter. Left hand side goes to your furthest inverter's right hand side. So this means if there's 3 inverters, this would have went from the first one to the third inverter's last one. If there's 2 inverters, from the first one to the second inverter's last one, and the second one on the first inverter to the first one on the second inverter, if there's only 2. If there's 3 inverters, first one to the last one, from there, the inside one, the second one to the first one, second one to the first one, and then the last one is bounded. There's 3 and there's 4. So you keep on with this pattern. This is for communication between the inverters when it's in parallel mode. So you can have a look there. Then you'll see the small red switch. Now, if there's 2 inverters, both small white switches on this red resistors must be on the on position. So the first one is on and the second one is on. But if there's more than 1 inverter in this string that you put it in for parallel, the first one and the last one is on, the middle one is off. Now this resistor tells my units which unit is the first and the last in the parallel line. So it knows how to loop back the information to the between the first inverter, that's my master, and the last inverter. So that just tells it basically you're number 1 and you're the last one. So in a system that's only 2 inverters, up, up, and up, up. If there is 3 or 4 inverters, you'll see the first one will be up, the second one will be down, and the fourth one will be up again. That's basically my parallel settings on the inverters itself without doing the settings on the screen. Dip switches, as I said, last one's on, and then the middle one's off. Cable work between them is a straight RJ45 cable. Now, this is where you do the parallel settings where I showed you on the online. If it's a single phase system, all of them will just be single phase parallel. Then batteries on this inverters that share. We recommend that you will use the same battery bank for all your inverters in a parallel system. So this means you can have 3 inverters that's pulling from the same battery, its power. The reason why we recommend this is your inverters isn't divided 100% equal between the loads. One inverter will always work harder than the other inverter, as well as your solar that's charging. One inverter will always charge more than the other inverter. If you split your batteries between your 2 or 3 inverters in parallel, you have the risk of one inverter that's running flat in a parallel system that will give an error and the system will shut down. If you combine your battery bank, then you have the capabilities of running one complete battery bank flat with the inverter. So that doesn't matter if one inverter is slightly working harder than the other one, the battery bank will still be fully utilized until the set value that you said it may not be utilized anymore. Now on batteries shared, if it's a battery that's communicating, only my master inverter is necessary for a communication cable between the battery pack and the inverter. My master inverter will relay all the information to the rest of the inverters. And if your communication between your inverters is correct, all my inverters will display the battery percentage and the power and all of that information. So that's basically that for parallel settings. I'll show you on the screens as well, Nano, a few of the settings that we can do there. Then 10 units in parallel. You can have up to 10 of my units in parallel. So that gives you a bank of 50 kilowatts of backup power of this inverter. As I said, battery shared is also enabled. So you can use one bank to supply all your inverters. Then you just have to click this battery shared enable option to tell the inverters that that's how it's working. Strings, each inverter has to have its own PV input. With that, I mean is if you have one string on the roof between 2 inverters, you can put that one string only on one inverter and it will charge, but you can't take that same string and give the power to one inverter and bridge the string to the other inverter and that both inverters run off the same power from one string. You have to have independent strings on your inverters, if I can put it like that. That's that for that one. And then, as I said, the master is the one that is switched on first. That's something a lot of people forget. So there's no master settings on my off-grid version. My hybrid version's parallel settings, that's for another day's training. That one has a master settings, but my off-grid version is the first one that's switched on, is my master in my system. So that's basically that for the training manual. I'm going to go over to the physically doing the screen settings on the inverter. A few of the settings there. You're more than welcome to stay if you want to see the settings on the screen. From here on, I'm just going to run through the settings. So the guys that knows the settings on the screen, you're more than welcome to leave. If you would like to see the settings on the screen, you can stay, and I'll switch to the other phone that says Yahoo screen. And that one's already focused on the screen, and I'll show you the screen settings if that's something that you would like to see. For inverters and parallel, can I run all household loads, including stove and geyser, on this inverters? You can definitely do that, yes. If you have 20 kilowatts worth of power, as long as you use less than 20 kilowatts of the system, you can definitely run everything off 4 inverters. If your geyser and your stove and everything is less than 20 kilowatts, definitely. But you must make sure that your battery bank and your solar panels is big enough to provide that load. If your batteries can't provide that load and the solar panels can't provide that load, you won't be able to run it. So you have to make sure you have enough panels and enough battery power to run the setup. Then as well, I forgot to mention, this unit can take up to 6.4 kilowatts worth of panels. So you can overspec it by 1.5 kilowatts of power on it. So you can add up to 1.6 kilowatt worth of panels. Okay, so from here on, I'm going to the screen settings. You can go to the one that says Yahoo screen. From there on, you'll be able to, let me just stop this one here on the training manual, so that all can see that other screen. Okay, so you guys can go to the screen settings from here. I believe everybody can see. Okay, just quickly going to move my equipment this side. Can everybody hear me from here? Nice and clear. Okay, as you can see, I'm focused here on my screen at this moment. I'm going to switch off all my circuit breakers. So now basically my machine is running in off-grid mode. How you can tell that is you have no line between your AC sign that's here to your inverter. So you see there's no line there. And if you wait, you'll see there is no, it will show you 0 volts and hertz on this moment. So for this machine, just the general to explain the screen to you, there's your battery information. There's your percentage. It will show you the volts percentage and how much power you are pulling from the batteries when you are using it. There's your panels. So that will also show a line when the panels is active, if it's working from the panels and so forth. So from the screen, you can generally see what your inverter is doing. So from here on, to go into your settings, you keep it in. You'll hear it's starting to change tone. So just again, it will make it will change the tone that it's busy with, but as well, you'll see it will start to flicker at the top. So that means you're in setting number 1. Here at the bottom, you'll see 01 with a spanner on it. That means you're in setting number 1. Setting number 1 is the date and time. So if you have a unit that's not connected to the internet, you'll have to set your date and time if you would like it to be set to whichever date. So I'm there on, that's fine. My year is right, my month is right, my date is right. Now time wise is 11:22, so my inverter's time and date is set correctly. So you press enter to go into the menu and enter to run through the specific setting that you're doing. As soon as you're done with the setting, you'll see the original setting is starting to flash. That means you're still in the settings and you can go to the next setting. So from here on, you go to number 2. Number 2 is that setting to tell this inverter how the PV is working. If you see this 2 lines, it means it's 2 strings that are going to the 2 separate MPPTs. That's the DC source one. And this one is when you have 1 string coming down connected to 2 MPPTs. That's when you have a system that's running basically on more than 13 amps from your panels. You're going to use this configuration and you're going to bond my positive and negative inputs on my MPPTs on the inverter. You're going to bond them. So your positive and positive on the inverter itself is going to be bridged, and your negative and negative for the 2 MPPTs is going to be bridged with your positive and negative coming in at 1 MPPT. So that means the current will be divided by my 2 MPPTs so that it can handle more than 13 amps per MPPT. So that's my MPPT settings for the solar panel. That's number 2. I just quickly want to see.
No screen.
You have to go to Yaku's screen.
Yeah.
You'll see there's another chat that says Yaku screen. Can you see it?
No, not at all.
You have to go through all the users, then you'll see there's a user.
Yes, but there's just a J in there.
No, that's my main one. That's the laptop I'm using. From there on, you'll see you have a lot of clients that's names are showing. You have to scroll through that so you find the one that says Yaku screen.
Oh.
So let's just quickly.
I click on it and nothing is happening.
Let me just see if I can help there. Yama, is it possible for you?
We can see screen from our side here. So he must look at the list of attendees there to look for Yaku screen on the list of attendees.
No,
Yes.
I've got it on top. You know, it shows their screen with a green light and so on. But if I click on it, nothing is happening. I can't see it.
You might need to change your layout on the screen. On the top right, there's different layout like speakers or the galleries or some other. Choose the first one. I've sent the screenshots in the chat box too. You can check the screenshot. Choose the speaker one, and then it ping the video of Yako's screen if you can. Then you can see the camera is in the middle of your screen, like mine. I will send another screenshot. Please check if you can set it right.
Yeah.
Okay, just quickly there. Can you see the list of all the users at the moment?
Yes. Yeah, it's
Okay.
on top of the screen. So I see Yaku's
Yes.
screen there. Okay, but if I click on it, it just shows nothing at the bottom.
Can you check the screenshot I've just shared and open the picture? You will find in the left part of your screen there's a layout settings, and go into it and select the first one. Then you can see there's one main video in the middle of your screen. Then you can choose which one you want to pin in the middle and go find Yako screen and pin the video. Then you should be able to have it at the biggest one. in your screen.
Yes. Yes. You can just, as you said, just go to my name, Jaco screen, right click on it. Then you see there's a chat, replace pin, hide non-video positive pins. So you
Yes,
can
please.
say replace pin and it should replace my pin and you should see my screen there on your side.
Okay, I've got it.
Okay.
Yes, thank you.
100%. It's a pleasure. So on setting 2, we've already done for the panels. Now, number 3. This is one of the first settings that you'll be able to start to adjust. So number 3 means this is the battery settings. Now, you can enter number 3, then you see the type that's flashing. Here you can decide which type of battery you're using. So type flashing now is lead acid. That's the same as user. You can go to the up button, then it shows you lithium ion. So that's when you have a lithium ion battery that can communicate, or no battery. You can use this unit without any batteries as well. So it will function then as a type of a grid tie type of inverter, that it will use ESCOM and the available amount of power from the panels to supply the load to the house. It will function like that, but it's not that effective as a fully hybrid with that specific function. So if you go to lithium ion, you press enter, then you see the battery brand will start to flash there. On battery brand, you're going to have to see which brand you're working with. As I said, in the manual, you'll see Pylontech is 2, Luxpower is 6, Dynas batteries is 8, and it will show a small column of them, which brand it is. And if you go online to your battery settings, you'll see in the online settings, there's a whole list that shows the numbers as well, if you'd like to familiar yourself with certain types of batteries that you're going to use. Now, -6 for my shorter battery that I'm having here. I'm going to press enter. You'll see the inverter goes on and off. That means it accepted the settings, and from here on, it's set. So now you have to go back to the settings. So we were at number 3 now. That's the battery settings. Your battery settings is set right. So we are happy with the battery settings now. The inverter is happy. It's showing you a normal status. It's showing you the percentage and everything. So it's happy with communication now. From here on, the next settings that you're really going to use is this is the buzzer. Some people don't like the buzzer sound. I don't have a problem with it. I enjoy the buzzer sound, so I know if I had an input on a certain button. Just want to enable my buzzer again. So I never turn off the buzzer, because with the buzzer, you know if you pressed a button. Okay. Number 6. Number 6 is your charging current. So number 6 is what the maximum allowed amount of charging current this unit will give to the batteries. This is the value, even if the BMS of the battery is asking you for 60 or 70 amps, but you limit it to, let's say, to 50 amps. Your inverter won't charge higher than 50 amps, even if the BMS is requesting higher than 50 amps. So I always like to set my settings on this, even if my battery is communicating, for safety purposes wise. If something goes wrong with communication, you know you can fall back on the inverter to keep your battery safe without overcharging it by setting this settings. So I've set it to 50. And as you see, if a setting is done, your original setting light will start to flash. Then you know you're done with that setting. Then, when you're on lithium mode, you won't be able to access 7 and 8. Number 7 and 8 is your float voltage and your charge voltage. That you can't set on a lithium battery that's communicating. That's between the battery and the inverter that is communicating. So if you have a lead acid setting, if you set number 3 to lead acid, you'll be able to enter 7 and 8. That's my charging and my floating voltage. So that's why you can't see it at this moment here. So that's why it's not here. Number 9 is my discharge amps. So if I go into number 9, this inverter is said it may not discharge more than 100 amps. Usually on a 5.1 kilowatt battery, most of them are half C. So you'll usually put it around 50 amps if there's one battery. If there's more than one battery, you can up that amount depending on the manufacturer specifications. Like my batteries, that Greenridge batteries, you can leave that one at 100 to 110 amps. The manufacturer said can go up to 2C without damaging the battery. So that 3.6 kilowatt battery can give you actually 6.2 kilowatts worth of power that you can pull any given time out of it. That's roughly 110 amps around there. That's more, 120, 130 amps. So this is just your discharge current amount that you can set on this inverter. So number 10. Now number 10 is basically you're telling this inverter with which settings it must work. If you have a battery that communicates, you're always working on SOC. That means state of charge with percentage wise. Now a battery that's communicating, you always run on SOC. A battery that can't communicate, you run on volts. Then all the parameters that you set in voltage will follow. If you put it back to SOC, all the parameters that it's following at this moment will be on the ones that you've added percentage wise. So that's what number 10 is, just to tell the inverter must I work with volts or percentage on the parameters that you're giving me. Number 11 is my cut-off voltage. Now, number 11 and number 12 works hand in hand. Number 11, you can't take it higher than number 12 is. So you'll see I won't be able to take it higher than 15%. That's the same as it will be when you get it out of the box. So your cut-off voltage can't be higher than your number 12 setting. So you first have to go to number 12, enter number 12, take it up to whatever value you will want to be. Number 12 is your on-grid discharge cutoff. So that means if I have Eskom power that's coming into my inverter at this certain point that you've entered in it, so that means 15% in my case, I want it to 30%. That means at 30%, your inverter will stop using the batteries while Eskom is available and go back to Eskom to keep 10% of your battery power for when there's a power outage. So in load shedding times, we put it something like 40-45%. You hit enter. So that means your batteries won't go below 45% while there's Eskom available. So your inverter won't use your batteries less than 45%. So number 12 is at 45%. Now number 11 is the setting where your inverter will completely shut off or shut down when it reaches this limit. So that means on a shorter battery, it's an 80% DOD that you really want to use it. It can go up to 90, but I don't like it at 90%. So it's a 20%. So at this moment, this battery will be drained until 20%. So when the battery reaches 20%, my inverter will cut off and stop using the batteries, and it will switch off until there's sufficient amount of power from the panels to start up charging the batteries, and it can go on again. So that's number 11 and 12. So these two settings goes hand in hand. You must work together with the settings, first 12, then 11. Otherwise, you can't do your settings. Okay, AC in just is the range within where you use this inverter. So that means you'll see UPS, if I'm not mistaken, is 90 to 270 volts, and APL is 190 to 280 volts. So you can leave number 13 as the factory sets it. So you don't have to play with number 13. So you can skip number 13 setting. Number 14 is an important setting. Number 14 is my AC charge. If your AC charge is not set right, your inverter won't use PV and battery power to provide power to your house, as I explained earlier. So it works the same as the app. You can disable it. You can see in the corner there's flashing disable. Then you know your AC charge won't be able to charge your system. But if you want it to charge your system, it's a cloudy day, you can enable it. And I always put it around 30 to 40 amps maximum that it will charge from the grid. Then SOC is that until where it must go. So in this case, I would just say 100%. So it will charge it till 100%. Your PV start time 0, 12, 12. So that's 12 o'clock at night. Now, I do this for my clients. I tell them, put it on 2359 for your P1. So that means it will charge constantly the whole day from Eskom. But I teach them the settings on the screen for when they see their batteries is almost flat and there's no PV to charge their batteries and they know they're going to have load shedding. You just teach your client, go to setting number 14, you enter on the AC charge, you enable it, and then you run through AC charge settings. I just want to quickly disable it there for you. Okay, so then tell them go enable your AC charge. Okay, now my AC charge is enabled. You tell them go through all the, just press enter, enter, enter through all the settings here. And then AC charge is on, and then the batteries will charge from Eskom. Okay. So from there on, the client can enable AC charge on their own time to charge the batteries whenever it's cloudy and there's no power at this moment. But if you have the app, you can also teach them on the app. It's much easier. All they have to do is enable or disable AC charge. The time frames will be set, so they can only go on the app settings, enable AC charge, leave it, see the batteries at 40, 50, 60% where they would like it, and go and disable the AC charge so that they have enough battery power left. Number 15 is AC first. AC first is when this unit will only use battery power, will only use Eskom to provide the load, even if there's sufficient panels. So AC first is only for a backup system. That means there's no panels and only batteries for when Eskom goes out. It's basically running as only as backup system. If you don't want it to run as a backup system, it's 0, 0 at all the settings. If you want it to run as a backup settings, 2359 at P1. And then basically it will always use Eskom as far as possible to provide your loads. The other piece is just different time frames. You can enter different time intervals where you wanted to use Eskom and not your batteries or panels. So then you run through all your end and start times. And that's basically it for number 15. Number 16 is my hybrid setting. That's where AC and PV can take load. Most of the time, the setting will be disabled. As I said, it will backfeed. But if you enable your hybrid function, you also have the option to feed back into the grid. If you wanted to feed back into the grid, you enable that function as well. And you can tell it the maximum amount that's available from the panels after all the from the output of the battery, that panel power will be fed into the grid. That's the hybrid function on the screen as I explained it on the computer as well. This is just for working with the battery. You're never going to play with 17, so you leave 17 as it is. 18 is for generator in. You can tell it what's the amount of power that it can take from the generator. Let's say 2 kilowatt. We're happy with 2 kilowatt. So that's that. Okay, this function here. This is the function when you have PV panels but no battery. You can technically run this unit without any Eskom and battery, only on PV power. So that means if you have a small farmhouse that only has a small fridge that's running, you can add 2-3 kilowatts of panels on the roof and only this unit. If the sun is shining and you have sufficient panel power, you don't have to have a battery in off-grid mode to supply the loads to your house. But that's a very tricky situation. Most of the times, if there's any load changes, the inverter won't handle it because your power from the panels can't handle load changes. So that's a setting that you're rarely going to use. Okay, so I just went out here. Gonna back to that setting. Okay, generator in, we've done PV UPS. You're never going to use this unit really like that. It doesn't work as it should. Okay. Okay. In this one is that's disable that one there. This is that eco mode that I've told you about. If it uses less than 60 or 70 watts at this moment, the inverter will switch off if you enable this eco mode. So you never want to run the eco mode on this inverters. So number 20, you're also not going to play around with. That's a setting that you won't change. Now, setting number 21 is parallel settings. Parallel settings on this inverters is quite easy on the screen. You don't have to do it on the computer. You go to this inverter is set to no parallel. There's 1 pH means single phase parallel. 3 pH means 3 phase parallel, and no parallel. If I go to a 3 phase parallel system, you set your phases here, 1, 2, and 3. That's ST and R on the phases, but you can do it on the screen. I'm just going to put it onto no parallel system. And the other thing is, as soon as your parallel settings is done, your inverter will switch off and on again. There's two settings that this happens with: your battery settings and parallel settings. Is the two settings that the inverter will switch on and off after the setting is done. So 21 is parallel settings. Just to show you, if you go to one phase parallel, there's 1P, that means one phase. You can't change that value. You can't change it to RS or T phase. It will always be on P1. And then from there on, I'm just going to go back to no parallel. Otherwise, my unit's going to be angry at me. Okay. It restarts again and you're done with that setting. And that's basically the settings that you'll be using on this inverter. That's parallel settings. That's for recording. That's for CT set. This settings doesn't do anything. It's for the hybrid one. You can't do anything on that. You can't do anything on that one there. Now, fan set, you also can't. That's if your fans are too loud for you. You can change the fan speed up and down. But we don't recommend that you play around with the fan speeds, because then your inverter has a chance to overheat if you bring the fan speeds too low. So you won't really play with that setting. So just to recap on this machine, there's a few settings that you'll always play with of change. First of them will be number 3. That's your battery settings. Number 6, your charging settings. 7 and 8 is your float and your charge settings for when it's set to lead acid. Number 9 is to tell your inverter what to use, voltage or SOC, for the parameters that you're putting in. Number 11 is your cutoff voltage. That's where your inverter stops working. Number 12 is for when it jumps back from the batteries to the grid, when grid is available, that percentage that you use there. Then AC in. Not going to use that one. Number 14 is for when you are going to have AC charge, if you would like to charge from Eskom or not. Number 14. And number 15 is for AC first. From there on, you can enable the hybrid function if you'd like, but 90% of the people don't enable the hybrid function. And then from there on, it's 21. So just to recap, it's number 3, number 6, 7, 8, 9, 10, 11, 12, 14 and 15, 16 and 21. That's the most common settings that you have to familiarize yourself on the screen. And that's going to depend if you can set your inverter correct without any internet connection. So this is how to set up this inverter when there's no Wi-Fi and you don't have to stress about a dongle to plug in the dongle and to get the settings done by the dongle. But doing the settings online is much faster and easier to do. So just going through a few of the work modes on this inverter. I've just enabled my AC, as you can see. So at this moment, I enabled AC charge. So it will show you AC charge at the top. So if you see that icon, then you know this inverter is able to charge from AC. So from there on, you can see all your grid information. Okay. So now you see I have load on the house. AC charge is enabled. So that's why my load is running through the house without going through. So my ESCOM is running my load at this moment. It's a small fan heater that I'm running. So that's what's happening there. That's why you see, if you see this icon, then you know AC charges or enabled or AC first is enabled. That's what that means. Now ESCOM is gone. Now it's load shedding time. My batteries is applying my inverter at the moment. So when panels is connected, your panel line will be there as well. So for this inverter, at this moment, because there isn't any panels, I've switched it on AC again. Let's see what happens when I go all the way to setting number 14 again. Okay, that one is disabled. Okay, all that is at 0. So we go into there. Okay, that's good. Okay. So at this moment, my inverter is going to set all its settings right, that the inverter, you can see at this moment, is running there up to the battery, and it's starting to transition from the battery to provide your load at this moment. You'll see my load from ESCOM is decreasing at this moment. So soon ESCOM won't be pulling my whole load. I'm pulling 2.2 kilowatts out of the battery, and my grid is not providing any power at the moment to my loads. So at this work mode that I've entered it now, its priority rise is solar panels with the battery will provide load to my house at this moment. So that's how it is provided now. ESCOM is away. The UPS icon comes up, grid is gone. ESCOM comes back on. My load is still running. Then you'll see it will slowly transition between ESCOM, and then it will go back to the battery, starting to provide the power to the house. So in this work mode, you'll see ESCOM is going down again. My batteries will start to run the house again. So that's how you can play between your settings to see what is happening at this moment. Is there any questions that one of you'd like me to answer at this moment? Chat. Okay. Yes, the dongle is included. Okay, so she answered you there. No, my machine doesn't include RJ45 for internet purposes. Unfortunately, not. You can only use the Wi-Fi dongle to get this machine online. Is there any other questions that one would like to answer? I think in the chat you will be able to access my training manual. It should be there as well. You can download it. Feel free to download it. Otherwise, I'm just going to post my number here again for you guys, so that you can WhatsApp me at any time. Any questions that you still have after this training session. If you're not added to the group, please leave your number here. We'll add you to the group, and on the group, I'll send that message again, the video for connecting the dongle to the internet, to assist a lot of you guys. So is there any questions or anything from anybody's side? And that is basically concluding the bulk of the training session for now, and then I'll be open for the next while to assist you with some questions and answering some questions if you'd like. So for now, I'm done. So you can definitely download the manual and go on. And then from there on, you'll feel free to leave. If there's anything that you'd like me to answer or explain to you more vividly or anything, please put your question down there and I'll answer you. I'll answer your questions as far as possible. Thanks for attending this training session. Feel free to WhatsApp me on this number if there's anything that you feel that we left out. As this is some of our first training session, so if you feel there's something that we left out, please feel free to WhatsApp me and tell me, listen, yeah, we would like to know more about this and less about this, so that we can smoothen out the process for the next clients and so forth. So thank you for visiting us here at Luxpower training today. And we hope that you learned something. And as I said, feel free to WhatsApp me and we can definitely work on answering some questions of you. Okay, on the shared MPPT side. Now, how that's going to work is you're going to set your inverter. I'm going to the screen quickly there for you. Number 2. Okay, you're going to put it on that setting that's showing you there. Now, what you're going to do is on the MPPTs itself, you have this machine has 2 MPPT trackers. You'll see it's A and B. So it's PVA and PVB. So PVA is positive. You're going to take one wire from the PVA positive running to the PVB positive. And from the PVA negative running to the PVB negative. So you're basically going to bridge your 2 MPPTs in parallel mode and only have one input that's coming in. So you can put that one input on PVA negative and positive, and then the other MPPT, because as soon as you parallel the 2 MPPTs, the load will be shared between them. That means the amps will be more than enough. You'll have technically 26 amps to run off them. So then you can have a string that comes down of up to 26 amps if you do it this method. You want to do this when you have panels that goes over 13 amps. At this moment, we have panels that the biggest panels that we have at the moment is 540s around there. And your 540s is at 12.9 amps. So my 540s is basically on my limit of amps on my MPPTs. So if you get a panel, let's say for instance in the future that's higher than 13 amps, you can do this. Or when you have a system that you can't build a big string for whatever reason, you can't string all of them and you have to parallel 2 of your panels, because as soon as you parallel 2 330 watt panels, you're over my MPPT's limit. So if you have to parallel 2 strings for whatever reason, then you can do it like this to keep it within the ampage range of my MPPTs. So it's not something that we do often, but if circumstances don't allow you to have your amps lower than 13 amps, it will work. Yes, as you said, the 5950 watt Canadian solar panel, I haven't worked with it myself, but if it's an 18 amp panel, then you can't use it on one MPPT. You're going to have to bridge my MPPTs to run that panel on this inverter. So for instance, in that case, that panel can work on my inverter. You're just going to have to put your settings to where I showed you. The 2 MPPTs connected to the same string, and then that 2 MPPTs will divide at 18 amps. So that means there will be 9 amps on an MPPT and it will still function 100%. So that's why they've added that function, so that you can double up on your strings on the parallel side and still be within your ampage range. So I hope I explained it well. If you still don't understand it, that will send me a WhatsApp. I'll also see if I can draw you a drawing as well, just to explain it slightly better. If you are still uncertain about certain stuff, then I'll definitely help you there as far as I can. Is there any other questions that somebody have? Okay. Okay, I can't find the attachment. Okay, that's fine. We'll send it now for you again. Is there a change over time when load transfers from mains to batteries? That's correct. It is. You're looking between a 10 and 20 milliseconds changeover at the moment. That's of all inverters. Inverters, that's why our output source is called an EPS. You see, all the inverters has a switch over time. Ours is between 10 and 20 milliseconds, usually more closer to 10. So in 90% of the cases, you won't realize the inverter has switched away from mains to batteries. But yes, we have a switch over time. So that's where a UPS system, a UPS is for uninterrupted power supply. A UPS doesn't have a switch over time, but our inverters, all inverters is EPSs. So that means it's an emergency power supply. So all of them have a switch over time. I hope that answered your question. If it didn't, just rephrase that question and I can try to see if I can answer it better for you. Yes. You'll see most of your hybrid units, as well as your Dayas, your sun sinks, all of them are exactly the same. They also have a switch over time. 99% of all your hybrid inverters also have a switch over time. So yes, all inverters basically has a switch over time. Even your Dayas, your sun sinks, your solar X's, all of them has switch over times. Most of them are between 10 and 20 milliseconds roughly. So sensitive lights, you get LEDs, that's quite sensitive. Sometimes it will show a slight dip, but most of our equipment doesn't notice a 10 to 20 second, 10 to 20 millisecond switch over time. Anything else that somebody would like to ask that we can explain for them? Feel free to pop any question or whatever. We are here to learn about this thing. So if there's anything that is unclear, no matter how small it is, you can ask it. We'll quickly see how far we can assist you. So you can ask any question about this.
Hello, everyone. Okay. Thank you very much, Jaco. Thank you, everybody, for joining us today. I think we can call it today, and if any clients have any problems, they can, or any questions, they can always ask us in the group, in the two groups. If you're not on the groups, please text me a message in WhatsApp. My name is Miao Miao. I'm in both groups, or you can always email me as well. I'll invite you on both of the groups. So I will also send the link of these recordings to the group, or share them on YouTube and send the links too. So if you're not having the full webinar training, you can always watch the recordings back. And thank you very much again for today. So I will end the meeting now, and any questions, please contact us. I think we have one last question from Jaco, please check this one. I've been having some issue connection Jenny to a 3-inverter single phase parallel system. Oh, he will call you, Jaco.
Okay, no, it's fine. I'll see what I can assist in that case.
Okay.
Okay, 100%.
Okay, thank you very much.
Yes. Thank you, guys. Have a lovely day. And any questions, feel free to call me or WhatsApp me on that number that I've dropped in the link, and I will assist you as far as possible.
Thanks, Jaco. Thank you again. Bye-bye, everyone.